Hello again. So today we're going to talk about isosceles and equilateral triangles, right? You might be saying to yourself, like, we already did that. Well, today we're going to take a closer look at these ones in particular. Right, so first thing we're going to do is we're going to start off with a definition that hopefully seems pretty familiar. Talk about what an isosceles triangle actually is. Right, so an isosceles triangle is when you have a triangle with at least two congruent sides. Right? If it has two sides that are the exact same length as one another, then you can call it an isosceles triangle. Right? We've got these different parts that we haven't talked about quite yet, but we are going to right here. So I'm going to try and color code it as best I can. Right? I'm going to do the base, and I'm going to color code it in red. What I'd also suggest is I know that it's hard to do that when you don't really have 1,800 colors or whatever. Right? So we're just going to put A, B, C, and D wherever these are on the diagram, so you know which one goes where. So the base of an isosceles triangle, right? Let's take a look at the diagram that we've got first. We've got a triangle. It's got two sides that have these little tick marks on them that show that those are the same length. It's also got these other markings down in these corners showing me that those angles are the exact same measure. So the base is down by, well, it's basically just this side that has those angles that are the same measure, right? It's that bottom side, if you want to think about it that way, if you line it up like that. Right, so that is the base of our isosceles triangle. Right, after that, we've got the legs. Right, the legs are the two sides that are the same as one another. Right, so both of those we would label as B. Those are the legs. As far as the base angles go, right, those are the two angles that are near the base. Right, so these ones that I'm labeling with C and orange, those are both base angles. Right. And then last but not least, if I'm trying to figure out where the vertex angle is, right, it's the only other angle. Right, so the vertex angle is that third one out, right? It's that like odd one that's not equal. So we've got two angles that are equal called base angles, two sides that are the same called legs. Right? We've got the base, we've got our vertex angle. Right? So we've got this isosceles triangle theorem, which is going to help us out. So what this is saying, and excuse me while I readjust the colors up there, what this is saying is that if two sides of a triangle are congruent, right, if they're the same thing, then the angles opposite from those sides are also going to be congruent. Right, so that's what we see in our diagram up top, right? We've got these legs, B. Those are the sides that are congruent. These base angles are the ones that are across from those sides. Those are the angles that are going to be congruent as well, right? So that's going to be pretty important, right? Being able to know that if you have two sides that are the same, those angles opposite from them are also the same, right? That's going to help us solve a couple problems. So in this one, we're saying that in this isosceles triangle, we know that from A to B is x minus 4, right? So as always, what I would suggest is when you have some information that's not on your diagram, write it in the diagram, right? We know that BC is x plus 7, and AC over there is 2x minus 1. Right? We want to find the measures of all the different sides of this triangle. Right? So you might be thinking to yourself, like, oy, they don't really give us a lot to work with here, right? But if we look at the triangle, right, it's isosceles. We know that we have some angles that are the same, right? I'm just going to highlight them here. Right? That's telling me that those angles are the same. We also have these tick marks showing that these sides are exactly the same length, right? So like we've kind of run into in the past, when you have two things that are the same, you can set them equal to each other. So I'm going to do that. I'm going to have 2x minus 1 and say that that's equal to x plus 7 here, right? Because those sides are the same, I can say that those expressions are equal to each other. Right? This sets me up with an equation that I can solve. I'm going to move my x's over to be on the left side. Right? So I'm going to get that x minus 1 equals 7. I then need to move that 1 away from the x's. So I'm going to add 1 on each side. And x is going to equal 8. Right? So we've now found what x is. Right? It still wants us to figure out what all the different sides of this triangle are. Right? So I'm going to give myself a little divider there. When I'm trying to find AB, right, that was x minus 4, right? So 8 minus 4, right, when we plug in that 8 we found out for x, that's going to leave me with a side length of 4. right? When I go ahead and try to figure out BC, that was x plus 7, right? So 8 plus 7 is going to give me 15, right? And then before I even do the last one, I already know what I'm trying to have it be, right? BC and AC in that diagram are the sides that are the same. I'm hopefully going to get 15 when I plug that in, right? On this one, it's 2x minus 1. So in this case, that's 2 times 8 minus 1. Right? So 2 times 8 is 16. Take 1 away, brings you down to 15 again. All right, so that's good, right? It's good that these ended up being the exact same thing because they're supposed to be equal to each other. Right? If we ended up with two different answers for those, we might say like, oh dear, let's go back to our equation, see if we solved it outright. Right? So let's give another one a go. Right? This one's telling me that we have another isosceles triangle. It's telling me that the measure of angle A is 8y minus 16. It's telling me that the measure of angle B is 72. And the measure of angle C is 9x. Right? We want to find the measures of all three angles of the triangle. Right? So on this last problem, we were talking about the sides. Right? We were working off the fact that those sides that I still have highlighted are equal to each other, and that was able to help us solve it. This one's not going to be all that different, except we got some angles instead of some sides. It's still going to be the same general idea. I know that this angle is congruent to that angle, right? Those ones that I just highlighted, right? So what we're going to be able to do is same thing as last time. We're going to be able to set those things equal to each other. So we're going to be able to say that 8y minus 16 is equal to, right? It's the exact same thing as 72. Right? So that gives me a starting point. Now it's an equation. I can solve it out. I'm going to add 16 to move that away from where my y's are. Right, so we're going to get that 8y is equal to, what's that going to be, 88. After that, I still need to get that y all by itself, so I'm going to divide by 8 on each side. Y is going to just be 11. Right? And again, unfortunately, we're not entirely done with this one yet. It still wants us to figure out what each angle is. Right? So the measure of angle A, they're telling me is 8y minus 16. Right? So again, it's 8 times that y we just found out was 11 minus 16. Right? So numbers are a little bit nastier on this one than they were on the last one. Let's plug that right on into a calculator, see what we get. 8 times 11, and then minus 16. 72. Whew. If you're looking at the diagram and you're like, didn't we already know that? Isn't that supposed to be the same as the other 72? You're exactly right. Right? So it's a good thing that this ended up being 72 because the measure of angle B was already 72, and they're supposed to be equal to each other. Right? So it ended up being a good thing that we wound up with the same number for both. As far as angle C goes, that one's the odd one out. Right? It's 9 times that x we found out was 11. So 9 times 11 is 99 degrees. Right? So after we go ahead with all of that, right, we are... Oh, actually, hold on. Let's hold up a second. I just realized C is 9x, not 9y. We found y. We didn't find out what x is. So sorry if you have to erase a bit, right? Measure of angle C is 9x. All right, so to do this one, we're going to have to figure out what angle C is supposed to be, right? So what I'm going to do is I'm going to, remember that those two angles we just found out, those two that are highlighted in yellow, are both 72 degrees. So off to the side of here, I'm going to write 72, and that other one's already got 72 in it. So how can we figure out that last missing angle? Right? So remember what we were doing recently, right? We were talking about the angles in a triangle. To figure out that third missing one, what I'm going to do is I'm not going to treat measure of angle C like 9x. I'm going to treat the measure of angle C as saying like, all right, we know we've got 180 degrees. And I know that I've already taken up 72 and also 72 with those other angles. So if I do 180 minus 72 minus 72, that's going to leave me with 36 degrees. Right? That sounds a little bit better than what we had before. Right, so measure of angle C is 36 degrees. If you wanted to solve that out, 9x is equal to 36 degrees. That means that x is 4, right? But all it asked for me for was to find out all the measures of those angles. We've done that, right? So you might notice I seemed pretty surprised when I was like, wait a second, that doesn't seem right. That's because I also made the mistake, right? It's okay to make mistakes sometimes as long as you catch them later. So be real careful on some of these. This one tried to trick us up by having y's and x's in the problem, okay? So let's take a look at some other ones. Oops, you might be able to see a little bit of example 4 there. So for example 3, if GH and HK are the same, right? So again, they're giving me information about this diagram, and I don't see that it's on there. So I'm going to put it on there. GH is the same as HK. It's also telling me that HJ is the same as JK. Right? It's also telling me that the measure of angle GJK is 100 degrees. It's pretty warm over there. Right? So what we're going to do is we're going to try and find all these other missing angle measures. Right? So this might seem pretty daunting. It's like, oh man, they're going to give me one number and I have to find the other 5. That's a lot. But what we're going to notice is that we have these isosceles triangles hanging out, right? I'm actually going to color code them a little bit better. Right, we've got this bigger triangle on the left. It's got these blue sides that are the same length as one another. Because those blue sides make it an isosceles triangle, I know that these other angles I'm marking in blue are going to have to be equal to each other. Same thing goes for the smaller triangle with the red sides. That's telling me that these sides that I'm marking, or these angles I'm marking in red, are also the same. Right? So if I'm looking for HKJ, this angle that's right up over there, the way that I could figure that out, right, I know that there's 100 degrees already taken up in that triangle. I know that K, like the angle by K and the angle by H, have to like share the leftover degrees. Right? So if it's isosceles, right, which it is, those are going to have to be the same. What I'm going to end up doing is I'm saying like, all right, 180 degrees total. I know about 100 of it. That's going to leave me with 80 degrees to spare. If those two leftover angles need to be the exact same thing, then what I'm going to do is I'm going to take that 80, right, and I'm going to say 80 divided by 2 is going to give me 40 degrees there. Right? So the measure of HKJ is 40 degrees. That also helps me solve for KHJ. That one's also going to be 40 degrees, right? Because it's supposed to be the exact same thing. Right? So both of those are 40. Right? And I know that this diagram can get a little bit cramped, right? So if you end up having room, I would suggest writing those in. It's good to have this information on there so it's a little bit easier to look at, right, and figure out what we're going with. The next one it wants me to find is GHK, right, which is this angle right over here. So to figure that one out, right, there's not really a super fancy trick or anything, right? All we know is that GHK, right, that yellow angle, and this blue angle here that we just found, altogether those make a straight line. If they make a straight line, that means they have to add up to be 180 degrees. Right? So if I know I have 40 degrees on one part of it, then I'm going to need another 140 degrees to get the rest, right? To get all the way up to 180. Right? So 140 degrees in there. For HGK and GKH, right, those are going to end up being the same measure, right? We already put that in there. It's going to be the same idea as how we found our first angle. We know that we've got 180 degrees in that angle total, right? So 180 minus that 140 that we already know about, that's going to leave me with 40 degrees. Because I have to split that evenly among the two leftover angles, I'm going to do 40 divided by 2, which is going to give me 20 degrees. Oops, I know I did that on the bottom one, but it's also the same as here. Right? So both of those last angles are going to have to each be 20 degrees. Right? Again, doing it the same way that we did that first one. Right? So what I'd like you to do is pause here, try out number 4. You can already see apparently that the first one is 30, right? But see if you can figure out the rest, right? Figure out why is that 30, right? So run through it the same way we just did number 3. So hopefully you gave it a go, right? what I've got here is I've got everything all marked down and all done out. Right, so we've got DE and CD that are the same. We got those sides marked in black with this one tick mark here and over here. Right, that's telling me that these angles, these angles are also going to have to be the same because it's isosceles. Right, the problem's also telling me that BC and AC are the same, so I've got those tick marks there, and again, that means that those angles are going to be the same on there as well. And we also know that the measure of CDE is 120 degrees. Right? So we can figure out that those first two are 30 degrees because, one, they're supposed to be the same. So once you find one, you know both. I do that same thing. 180, take away the 120 we know about, leaves you with 60 degrees left over. And if you need to split that 60 degrees evenly, each one of those has to be 30. Right? You divide by 2. The measure of BCA right over there is 30 degrees because it's vertical from that other 30-degree angle. Right? These are opposite from each other in that intersection. The last two, right, 75 and 75, same idea. We're going to take that 180, take away the 30 we know about. That's going to leave us with 150 degrees to spare. To make sure that they come out the same, I need to take that 150, split it in half. It's going to leave me with 75 degrees for each one of those last two angles. All right? So hopefully that went pretty okay. I have good news. If you were looking at number 5 and you're like, yeah, I don't know, we are going to skip over that for now in the interest of time. We might talk about them a little bit during class, but with the way this trimester is going, I don't know. We'll see. All right, we're going to move on to equilateral triangles on the next page. So an equilateral triangle, again, you might already remember this from when we were talking about classifying triangles. To be equilateral, it's a triangle with all 3 sides have to be the same length. Right? So all 3 sides the same length. We also have these things called corollaries to the isosceles triangle theorem. Again, we're not really worried about what it's called, more about what it's trying to tell us. Right? So what we're going to say is that a triangle is equilateral. Right? All its sides are the same length if and only if it's also equiangular. Right? So equiangular is a word that we kind of briefly touched on in the past, right? It's basically saying the same thing as equilateral, right? Equa meaning equal, right? And then lateral means sides. Angular means angles, right? So they have to have the same angles, right? The second part is saying that each angle of an equiangular triangle measures 60 degrees, right? They all need to be 60, right? Because if you need to split 180 3 ways evenly, right, they have to be 60. There's no other way, right? So what we're going to do is we're going to take a look at a problem that's a little bit, I'm not going to say it's an easy one, right? This one is a little bit complicated, but bear with me. I'm hoping that it'll be pretty all right. We're going to assume that EFG is equilateral and that EH bisects angle E, right? So we're going to try and find the measures of angle 1 and angle 2. So to do that, right, the important part is that we know that this is bisecting angle E, right? This line right here is splitting angle E in half, right? So we got to think to ourselves, like, all right, what was angle E? All right, angle E was 60 degrees, right? It's equilateral triangle. All those angles are 60 degrees. So if I then took that 60 and I split it in half, right, that's what bisect means. And that means that each one of these other angles is going to be 30 degrees, right? So measure of angle 1 is 30 degrees, and so is angle 2, right? Not too bad, right? So it does have us recall that bisect means split in half, right? So don't forget about that. It is going to be important when we're talking about triangles, as we can see. We also then want to find the value of x, right? And this one can be a little bit tricky. So to find the value of x, I'm just going to work on just that side of the triangle. What we need to do is we need to start by saying, like, all right, what I know is that all the angles in a triangle add up to 180, right? So I know that angle 1 plus, and I'm going to kind of throw some numbers in there, right? We have angle 1, we have an angle 2. Let's call this angle 3 down there. So angle 1 plus angle 3 plus 15x all comes together to equal 180, right? That's those three angles in that triangle that's on the left here. Right? Some of this we already know. We know that angle 1 is 30 degrees. Right? We also know what angle 3 is. Right? You might not think we do, but we do, right? If we zoom back out, take a look at the whole picture, this is an equilateral triangle still. That angle down by F is 60 degrees. Right? So we can actually, we'll still refer to it as angle 3 down there, but I'm going to put that 60 on the inside just so it's a little bit nicer to look at. So we know that we've got a 30 and a 60 and a 15x, and they all come out to be 180 together. So now I can solve this out, right? I have enough. I can just move those numbers away from the x's and figure it out. So when I combine those like terms, 30 plus 60 is going to give me 90. After that, what I need to do is need to move that 90 away from the 15x. Right, get those x's closer to being all by themselves. Right, so 15x equals 90. After that, we just need to divide by 15. Then we're going to be good to go. X is going to equal 6. Right? And thankfully on this one, that's all it wanted us to do. Right? I know that most of the time it's like find X and then plug it back in for 6 other pieces of this. Right? That's all it wanted, was it just wanted X. Right? We got a little bit more to go. On this diagram above, we're going to draw another line in there called EJ, so that EJ bisects angle 2, and that point J is on that base side, right? It's on that bottom side of the triangle. Excuse me. So what we're going to do is I'm going to draw that in as best I can, right? We're never going to be perfect, but I'm going to try my best to bisect angle 2 just like that. And so again, bisecting it means that we cut that angle in half, right? So what I'm actually going to do, and I'm going to focus on the diagram for just a second, is angle 2 was already 30 degrees. If I split that in half, then each little piece of this is 15 degrees, right? So we're still splitting it in half. Cool, so that's all part C wanted me to do, was it just wanted me to draw that in there. Cool, done. Ding. Oh boy, this is where it wanted us to do that, right? I should put a little J on there. That is where we're intersecting at that bottom piece. On the diagram above, right, we want to find the measure of HEJ, EJH, and EJG. Yikes. So, HEJ, right, that first one. If I'm looking at my diagram, we've already got it. That's pretty nice. HEJ is one of those 15 degrees that we split up into, right, when we bisected angle 2. So HEJ is 15. EJH, right, is this one that I'm going to highlight here in blue. That one is going to require a little bit more from us. So I'm going to focus on just the diagram for a second. In this diagram, we're looking for that blue angle. We know about the 15. But then we need to ask ourselves, do we know what this angle that I just put the question mark is? Right, so you might be thinking to yourself, like, all right, this was 90 over on this side, right? 15x was equal to 90 in part of our last problem. So that must mean that this part is also going to be 90 degrees, right? Because they got to make a straight line together. 90 plus 90 gets you there. So I know about 15, I know about 90, and then to figure out that last side, I'm just going to take those away from 180. Right? So again, for over here, EJH, we're going to do 180 minus 90 minus 15. Right? That's going to leave me with 75 degrees for that blue highlighted angle. All right, I'm just going to pop that in my diagram as best I can. 75 degrees. Whew, there's a lot going on in there now, but we only have one piece left to go. Last but not least, we've got angle EJG. To figure out EJG, which is this one right here that I just put in green, right? I need to think about, like, all right, what do I know about this? So there's actually 2 different ways that we could solve this, right? Which is kind of nice. You know, we use whichever one makes more sense to you. So one way that we could do it is we know that that blue and that green angle with the highlighter in them add up to give you 180. So you could do 180 minus the 75 we know about, right? that's going to leave you with 105 degrees for that highlighted green, right? The other way that we could get this one is kind of similar to how we did part B of this, right? We know that angle G over in that other corner there has to, oops, oh goodness. Angle G over here has to be 60 degrees because, again, we're still working in this big equilateral triangle. If I know that that's 60 and I know that I also have that 15 a little bit further up, I can do 180 minus the 60 minus the 15, and that will also get me to the same place of knowing that this is 105 degrees there. All right. So I know that this is, especially this problem, not particularly easy, right? There's a lot going on in this one diagram just for this one problem, right? But the important part to remember is that equilateral triangles, all of their sides are the same, all of their angles are 60 degrees, right? They're all the same as well. All right, so in the interest of making sure I don't talk too long, and I also got a sneeze coming on, so I'm going to talk to you later. Be sure to ask questions if you have them, and I'll see you next time.